Hello friends, now let us move on the next video of isoparametric elements and numerical integration. Here we are doing the study of quality checks. It is a total theory lecture but very useful from the examination point of view, because generally in examination one or two aspects or the quality checks they are asking, and they are asking the definitions or the differences between these two. So whenever we are selecting for the isoparametric element, this for the meshing we are using ideal shape. For the quadrilateral element is the rectangle, and for the triangle we are selecting the triangle one. So different quality checks parameters are the skew, aspect ratio, included angles, and the Jacobians and the stretches. So what we are checking here, that whatever the answer we have getting through the calculations, is it very close to the exact solution or not? And for that purposes we are checking so we are putting the certain quality checks. We knows very well, when we are considering the square element, means its all angles must be 90, and when we have considered the triangular element, then the all angles must be 60, and according to that we are defining a various quality checks parameter. So the first one, the very first parameter is called as the wrap angle. Now wrap angle means what? That is out of the plane angle. So if we have taken a rectangle, okay. So if through this one, if I draw a diagonal, then this plane and this plane should be in the same plane. It should not be changed. If this angle, if this plane is lifted by this value, or we could say, if I would say that if I draw a line from this one, and if this one is lifted by a certain angle, if this line is lifted by a certain angle, and this angle, so it must be a 90. With respect to this one, it must be a 90. But if this one is changing, instead of that this angle is shifting to here, means this end is shifted to here, then that is called as the wrap angle. So it looks like this one. So this is my one plane, and this is my another plane, another plane so this is called as the wrap angle, and this ideal values should be 0 degree centigrade, but the acceptable is less than 10 degree, so this wrap angle is defined as the angle between the two planes formed by slitting the chord element along the diagonal. Maximum number of angle out of the two possibilities is reported as a wrap angle. Then the second term is the aspect ratio. This is very important. This one is the ratio of the highest dimension to the shortest dimension. The higher value of a aspect ratio increases the inaccuracy. It means that if your aspect ratio is larger, then your result is not very accurate. Your result is inaccurate. So now see, this is the element we have selecting. So this is the thickness is 1, and the height is 1 and thickness is 12. So aspect ratio is equal to 12 divided by 1. So when we are selecting the 12 divided by 1, my aspect ratio is 12. Now here there are another element, the same rectangular element. The values are 3 and 4. So aspect ratio is equal to 4 divided by 3. This is the 1.33. So this gives the poor result, and this gives the somewhat better result. But ideal one is 1. That ratio should be 1. Means that if this is 3, then it must be a 3. Then and only then we are getting a more accurate result. So this is the aspect ratio. Then we are moving on the skewness. Now skewness is defined as the deviation from the regular polygon. So if I draw a regular polygon, now this one is my regular polygon. If I draw the diagonals from this one, So whatever the angle we have developed here, it must be a 90 degree. It must be a 90 degree. So acceptable value is 0.01, or there should not be a difference. Means only 1 degree difference can be considered, but not more than that one. So even though for the triangles also we need to consider this is the triangle. If we draw the diagonals of this one, and whatever the angle we have developed into these diagonals, that must be a 90 degree, that must be a 90 degree. So this is called as the skewness. This is called as the skewness. Then the Jacobian. So it is the scale factor arising because of the transformation of the coordinate system. We have already studied what is meant by the Jacobian, that for transforming a natural coordinate system to the global coordinate system, we are using the Jacobian, and this Jacobian is defined in the centroid one. So ideal value of the Jacobian must be a 1, or acceptable greater than 0.6. Then we are moving on the distortion. So ideal value of a distortion is 1, acceptable is 0.6. Now what is mean that it is a distortion is defined as a absolute value of a Jacobian multiplied by a cross-sectional area multiplied by local coordinate system. This is the area of a local coordinate system. So Jacobian multiplied by area of a local coordinate system, LCS. So this is the local coordinate system divided by area of a GCS, so global coordinate system, that is called as the distortion. So this is also the ratio, defining as the ratio of a absolute Jacobian multiplied by local coordinate system area divided by the global coordinate system area, that is called as the distortion. The value is 1, or acceptable is greater than 0.1. Then the stretch, the ideal value is 1, again it must be greater than 0.2. Again this is the minimum value, and this one is the d max value. This is again the ratio L minimum multiplied by root 2 divided by d max. This is the my stress. This is the my stress. Then if the element is triangular, then the element is the triangular, then the stress is equal to R multiplied by root of 12 divided by L max. So this is my triangular element. In that one, just I have draw the subscribed circle, and then this is my L max, and this one is my R value. R value. This is R value. So this is the skewness. Then the included angle. Included angle, that is the skewness consider overall shape, but included angle consider into the account individual angles of a quadrilateral or the triangles. So the quadrilateral, that must be a 90 degree, and this one is the 60 degree only. 60 degree only. Then adaptive meshing and the geometric associate meshing. So adaptive meshing means what? If the solution of the problem generates the non-acceptable error, if the solution of the problem generates the non-acceptable error, and if one is to be managed by using H or P refinement, H or P or R refinement, this is the R refinement, then such type of the adaptation itself is called as the adaptive meshing. What does it mean? That you just whenever you are getting the solution, and if there is an error occurs, then the solution, the meshing itself is changing. Instead of that one, they are using H or P meshing, or the R meshing, and according to that the results are improving. That is called as the adaptive meshing. Then the second one, that is the geometric associative meshing. So in that one, whatever the geometry is associated, according to that the elements are changes. So sometimes there is a triangular element have taken, sometimes the rectangular element have taken. According to the geometry the meshings are automatically adjusted, then that is called as the geometry associative meshing. Then the differences between the H and P refinement. This one is we have already studied in into a previous chapters. That is when the number of elements are increases, and when the only the order of a polynomials are increasing. So this one is we already studied. I do not want to explain a lot. You read this one and then we proceed. So if you read this one, let us take some pause and read this one loudly. So in a H version of a refinement, that your elements are divided, uh, then there is a order is changing, then there requires the more time for the conversion, then the remeshing is required and applicable for all type of the analysis, and the vice versa is given here. Then the uniqueness of the mapping. So when we are transforming, when we are doing the transformation from the your natural coordinate system to a Cartesian coordinate system, then the determinant of the Jacobian matrix should not be negative. So if the determinant of the Jacobian matrix is negative, then the answers are not correct. So you can see such type of the distortion, and this type of the distortion, or this type of the uneveness, or this type of the distortion we can observe, and hence it should not be considered, or it one is not taken very positive one. So there is a necessity of the uniqueness of a mapping, and it one is calculated by the determinant of the Jacobian matrix. So determinant, if the determinant is negative, then it one is not the unique one. The basic rules or the theorems for the isometric transformation, this is again sometimes asking into a examination. You will go through that when read it by stopping the video and understand what is given. Actually you would be now able to understand what is given into this one. You stop the video here, read at own level, and then understand these theorems thoroughly. I do not want to waste the time on these issues. So thank you to all of you for patiently watching the video. Thank you.